Good afternoon to all. I would like to present my paper title Acoustic Analysis of Vowels in Kokborok for Male and Female Native Speakers of Tripura. Starting off, I would like to introduce myself as Professor Shonirbhar Mujumdar from Tripura University Department of IT. This work is done with one of my students who is a PG student, Mr. Shuman Dev Burma, who hails from the tribal community of Tripura, and that's why I have taken up his language as his project. So he has done this work. So starting off in this work, what he has done is firstly uh, we have collected the data of the native speakers. Here, Tripura is a small state of northeast India. So here, what we have is we are having this Kokborok speaking people. These are mainly for the Borok or the Tripuris, who are a Sino-Tibetan linguistic group. And here there are a lot of tribes who speak the Kokborok language, the Nuatia, the Deporma, the Chamatia, the Viang, the Koloi, the Murasing, Rupini, Tripuri or Tripura, and Uchol. So they have the common language Kokborok. It is a low resource language, and we have very few speakers, but it is one of the official languages of Tripura. So it, unlike the English language, has 6 vowels instead of along with the AIOU, there is another extra vowel, and we have 21 consonants. And here, what we have done is that we have tried to do the language identification, and most importantly, as among the many states of India, Tripura is one of the states where Bengali and Kokborok are both official languages based on the residents of this state. So in this northeastern state of Tripura, we have this Kokborok as one of the primary languages and official language. So we have used that as our field of study. Here we have used the techniques which is formant based analysis. We have used the Pratt factor for that, and the popular MFCC, which is male frequency substitution coefficient. And, but what we have done here is that we've taken the spectrum of that and analyzed it using the deep learning model of AlexNet. Next, starting with the introduction, this Kokborok is a linguistic communication which these Borok tribes, the 9 tribes that I referred in the previous slide, they use that is available in Tripura, and Tripura is having around 70-80% border with Bangladesh. So Bangladesh also has a few people speaking this particular language. So here there are 9 major social communities, and this word Kokborok, which is the name of the language, means the language of human, where Kok means language and Borok means human. So this was the one which was coined by the people here, and they call their language Kokborok. And in spite of being from different tribes, they speak the same language. And they were under one king, and because initially it was a princely state. So we have analyzed the 3 primary formats using the Pratt software. We have used the databases of male and female native speakers of Kokborok of different tribes here. We have mixed them up, and we have taken these language speaking people from the different regions of Tripura. Some are from the urban regions, some are from the rural areas. They are having different dialects, so to make this whole thing tribe independent or the dialect independent. So the purpose of this study is that Google already has introduced 24 new languages to this Google Translate. Among them, of these 8 northeastern states of India, 3 northeastern languages, that is Manipuri, Mizo, and Assamese, which are from for the speakers of the state of Manipur, the state of Mizoram, and the state of Assam, is already included among the 24. But Kokborok is not included, and Tripura is one of the more population uh, related because it is highly populated among the northeastern states along with Assam. So that's why the importance of Kokborok is there. So this Kokborok language is yet to be introduced by Google Translate. So that's why we are doing the acoustic analysis of vowels of Kokborok, which may be beneficial for the language identification, whereas this is one of the official languages of this state of Tripura, as well as there are many areas of Bangladesh where this language is spoken. So we have worked on both male and female people of the among the native speakers of different tribes. But we have used only 14 different sounds because initially we have not used all possible words, rather we have used all possible numbers that we could do. So starting off here, what we have is that the main contribution here happens to be the database creation of the number system, as well as segregation of male and female native speakers irrespective of their dialectical differences. The methodology that we have employed here is that the three primary formats of frequencies, that is F1, F2, F3, have been used to differentiate the different vowels. The F1 in the vowel is normally inversely related to the degree of backness, and F3 is for identification of speech contrast. We are not here. We are not using F3, but we have identified it for the future for prospect. We have used mainly F1 and F2 along with the MFCC. The formats correlate with the tongue and height of the tongue positions, and these are evaluated based on their correlation among them. And other than these two formats, we have already used the mel frequency MFCC spectrum analysis using AI and deep learning, as I referred in the first slide. And here we have employed only one model, that is the Alexa model. So the data collection here was done in different closed areas by Suman, and he has used no noise to cut back the extra noise, low noise amplifiers, and LNA based headphones, and tried to use the standard noise cancellation facilities as much as possible. The text material of Kokborok number system that has been used is 1 to 1 lakh, or say 100,000. Here we have used the terms 1 equal to sa, 2 equal to 9, and many, but we have only 14 different because here we don't have 11 or 12 kind of thing. So here we are having uh, uh, 10 1, 10 2 for 11 and 12. So here we have used the four components. The data that we have used, you can see here 1, 2, 1 to 9 we have used up to 10. After that, it is say after 10, what we have is 11, 1 is 100. So after 10, we have 100, we have 1000, we have 100, and say 1 crore. We have not gone up to 1 crore, we have gone up to 100,000, that is 1 lakh in Indian number system. Because here you can see 11 or 12 is written as 10 1 and 10 2. It is Chi Sa and Chi Nui, where Chi is 10 and Sa and Nui is for 1 and 2. Similarly, 20 and 30 are written as Nui Chi. Nui is for 2 and tens is Chi, and 30 is Thumb. You can see 3 is Thumb, so 3 tens is taken as 30. Similarly, 99 is Chuku Chi Chuku. Chukuchi Chuku means 9 tenths and 9. So, 500 is Bara, where Bara here is Ra is for 100 and Ba is for 5. So 500s. Similarly, we have this 500, 5,000 as Ba Sai I, where I is for 1,000, Sa is for your 100, and Ba is 5. So it is 5, uh, and you have a Sa for this one, 5 and 100, and I is for 1,000. So 500, 1,000. 5 size 1,000 and 5. So 5 1,000. Similarly, 10,000 is G Sa I. I is for 1,000, 1 is for Sa, and G is for 10. So this has been used over the time, and this is how we have done it in Pratt. The Pratt software handles this in this way. You can segregate the terms, you can do the directory difference, and formats will be calculated. Here you can see for SA or 1 how we are calculating it using the text read file, and this is for 50, or bar G. Bar is for 5 and G is for the tens, 5 tens, bar G. So this here what we've used for any vowel, say nucleus vowel A, how the durations are happening, we calculate the durations, and based on this duration, we have the formats coming up. You can see format 1, format 2. We can differentiate here, and this is the MFC which is used for the MFC calculation. This is a standard model we have taken up for literature, just redesigning our proper format. And based on the durations that we have obtained for the different vowels, you can see the difference for male and female, what the difference is in terms of the millisecond. And based on that, we have to plot the F1 versus F2 for the 6 vowels, and based on the format 1 versus format 2 in hertz. And this is the interrelationship correlation which you can see from this graph. So based on that, if you take the confusion matrix of F1 and F2 with respect to the durations, you can see we are having 65% accuracy and 68% accuracy for the females and males, and similarly 72 and 74 when we use F1, F2 and duration together. For the LXNet model, we have used the NFC spectrogram and applied the deep learning network, and we obtained the confusion matrix. And there, after training and validation, we have obtained around much significant more result, like 98% for the males and 99% for the female, which is approximately equal to nearly 100%, if not exactly 100%. And exactly 100% is practically impossible also. So that is one of the criteria. In spite of that, we have got, you can go back to the previous slide. You can see here what we have done is we have used this nucleus. We have got the spectrograms, and we have the deep layer networks for this. We use pre-trained LXNet here and done the prediction. So based on that, to conclude, what we have is that here in this paper, we have the experiment study which was carried out for the roles of the vowels. And the uniqueness of the work is that we have used both male and female for the 9 different dialects to make it independent, and for all of them, we have got a good amount of result. So thank you very much. I don't use the uh, uh, app that you have used, that's why I'm sending this recording version. I hope if you have any queries, I'll try to be online. If I will be online during this session, I'll try to answer that. So thank you very much. I'll try to pick up the questions on the chat box.